Okay, this is section 6.6. When we finish, we want to be able to verify and use properties of trapezoids and kites. So the first thing we're going to do is we're going to start off with some terminology. So we want to know what is a quadrilateral with exactly one pair of parallel sides. That is a trapezoid. And the parallel sides are called bases. And the non-parallel sides are called the legs. And the angles that share a base are called base angles. And there are two sets of base angles in a trapezoid. Okay, so this is a picture of a trapezoid. So we are going to label the parts. Okay, so one little notation is missing, so I'm going to go ahead and I'm going to put it right here. So they didn't have those sides marked as parallel, so I added that. So the top part is called a base, and this bottom one is also called a base. So remember, the bases are the two sides that are parallel. The non-parallel sides are called the legs. So right here are my legs, and right here are my bases. Now, what about the base angles? Now remember, there are two sets. So the base angles are located. Here's one set of base angles. And here is the other set of base angles. Okay, so of course there is a special trapezoid. So a trapezoid with congruent legs is called an isosceles trapezoid. So let's see if I can spell that. I-S-O-S-C-E-L-E-S. Isosceles trapezoid. So I have my trapezoid ABCD. BC and AD are parallel. AB and CD are not, but the legs are congruent. We have the congruent markers, so we know that this is an isosceles trapezoid. So now let's take a look at Theorem 619, and it says if a quadrilateral is an isosceles trapezoid, then each pair of base angles is congruent. So that means that angle T is congruent with angle P, and angle R is congruent with angle A. Now this is only true with an isosceles trapezoid. Now let's take a look at problem 1. CDEF is an isosceles trapezoid. The measure of angle C is 65. It wants to know the measure of angle D, angle E, and angle F. So let's take a minute to look at that. Well, the first thing I know is that angle F is 65 degrees. Now, how do I know that again? I know that because base angles of an isosceles trapezoid are congruent. Now, how can I find the measure of angle D? Well, I know that the measure of angle C plus the measure of angle D is equal to 180 degrees. So 180 minus 65 is going to give me 115. So I know that the measure of angle D is 115 degrees, and E is also 115 degrees because we have an isosceles trapezoid. Now, how did we know that the measure of angle C plus the measure of angle D was equal to 180? Well, there's a couple of ways. So if we were to extend this, DC is my transversal, CF and DE are parallel, so same side interior angles, the sum is 180 degrees. Now let's take a look at problem 2. So this one, I want you to look at it for a minute. So go ahead and hit pause and look at it and see what information it is that we need to know. So I have to figure out how I can get some numbers, right? So right now when I look, I've got X is what I'm looking for, Y is the other thing I'm looking for. Then I have this angle 1, and, oh wait, this seems to form a triangle, and not only does it form a triangle, it is an isosceles triangle. So I'm going to be able to use that. Now, how can I find out what angle 1 is equal to? Okay, so, oh, let's see. This should have 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, it does. Don't you love listening to me count? So, how many degrees is a full circle? So, a complete circle is 360 degrees. How many pieces is it broken into? It's broken into 20, so we're going to divide 360 degrees divided by 20 to find one of the angles. And 360 divided by 20 is equal to 18 degrees, so we know that the measure of angle 1 is equal to 18 degrees. Now this is the point that knowing that this is an isosceles triangle is going to be your very best friend. So if this is 18 degrees, what is the measure of these bottom two angles? And you could have looked at it, you could have looked at these angles as well. But I'm going to look at the bottom two because I want to solve for x. So how can I find that? So I'm going to say 180 degrees minus 18 is equal to what? 162. So the sum of these base angles is 162. So what am I going to do to find each angle? I'm going to divide it by 2, right? So 162 divided by 2 is equal to 81 degrees. So I know that angle X is equal to 81 degrees. Okay, now I need to find angle Y. So there are several ways that I can do this. So if I know that this is 81 degrees, these are parallel because they tell me it is a trapezoid. So I can do same side interior angles. 81 plus y equals 180. Or I can use corresponding angles. This angle is congruent to this angle. So this is 81. And then I could use linear pair. So either way will work. So now we're going to say y is equal to 180 minus 81, I'm sorry. No, that's right. 180 minus 81. So angle y is equal to 99 degrees. So even when it looks like you have absolutely nothing, with geometry, there's always a way to find something. Okay, so now let's go to theorem 620. So if a quadrilateral is an isosceles trapezoid, then its diagonals are congruent. So we're going to use mid-segments again. So we learned about mid-segments of triangles. It's going to be very similar with trapezoids. The mid-segment of a trapezoid is the segment that joins the midpoints of its legs. And that mid-segment has two unique properties. Okay, so let's take a look at theorem 621. So if a quadrilateral is a trapezoid, then the mid-segment is parallel to the bases, and the length of the mid-segment is half the sum of the lengths of its bases. So that means that segment MN is equal to half of RA plus TP. Okay, so let's take a look at problem 3. So we're going to be using the mid-segment of a trapezoid. So what does it say? It says segment QR, which is right here, is the mid-segment of trapezoid LMNP. And it wants to know what is X. So let's set up what we do know. So we know that segment QR is equal to half of LM plus PN. So we know it's half of the sum of the bases. So now I'm just going to plug in what I know. So I've got x plus 2 is equal to 1/2 times 4x minus 10 plus 8. Now I'm going to combine my like terms. So I've got x plus 2 is equal to 1/2 times 4x minus 2. I'm going to distribute the 1/2. Another thing you could do is you could multiply both sides by 2, because 2 is the reciprocal. In fact, I think I'll do it that way. You could either distribute the 1/2, or you could multiply both sides by 2. So now I have 2x plus 4 is equal to 4x minus 2, because these 2's cancel out, minus 2x plus 2. So now I have 6 is equal to 2x. Divide both sides by 2, so x is equal to 3. Okay, we're in the home stretch, I promise. So now we're going to talk about kites. Not the kind you fly, but a kite is a quadrilateral with with 2 pairs of consecutive sides congruent and no opposite sides congruent. So consecutive sides are congruent. Consecutive sides are congruent. So we have 2 pair of consecutive sides that are congruent, and opposite sides are not congruent. Opposite sides are not congruent. So let's take a look at theorem 622. If a quadrilateral is a kite, then its diagonals are perpendicular. So in this case, our diagonal is AC and BD. And what happens? AC and BD are perpendicular. And then this last thing is just a summary. So I'm not going to go over that. You can take some time and look at that. That kind of like gives you a visual representation of everything.